All right, and we are back. Question 10, which is really actually 6 questions, but all they're asking you to do, each one's asking you to simply rewrite it or factor it. So let's change this. Oh, let's go to blue. When you have two terms like d squared and 5d, it's, I don't know, it's kind of tripping up a couple of students, right? But maybe it's because I'm looking for an m squared, an m, and a 30. So some kids are looking at this, right? And you're like, okay, so I know that I have to have two parentheses here and a plus and a minus. Well, it's not necessarily the case. When I just have d squared and 5d, what I'm looking at is identifying, well, each term has at least one d, right? So this is d times d, this is 5 times d. So in other words, I can factor out one of the d terms from each component and say d plus 5 times d is going to allow us to factor that out. Really what we're trying to do is eliminate this whole squared term. When we can get rid of a squared term in the expression, we can do a lot more with it with our algebra. We can solve for where does this graph cross the x-axis? Where does it cross the y-axis? You know, we can do a lot of that stuff once we've eliminated the squared term. So A is a little bit simpler than people are making it. We're just simply trying to get rid of the d in both terms, right? So moving on, B. B is your traditional factoring, your algebra 1, your algebra 2. Here's a trinomial, right? There's 3 terms, so a trinomial. Give me a set of parentheses. So again, what we're shooting for with these, it's 2 numbers that multiply to 30, that when you take those same 2 numbers and add them together, they equal negative 13, because you have to account for that term there. So what 2 numbers go to 30? So I'm going to write that over here. So I've got 1 and 30. See, this is why we did that part up here. Where the heck did that go? Oh, right here. That's why we were practicing in question 8. What are all the factors that do this? What are the factors that do that? Well, it comes down to question 10. So 1 and 30, 2 and 15, 3 and 10, 1 and 30, 2, 15, 3, 10, and 5 and 6. Now, when we go to look at these numbers, yes, they all multiply to positive 30, but I have to get to a negative 13. So if I just put negative signs in front of one column, and then I multiply it, I'm back to not negative 30. So if I keep them both as positives, I get a positive 30, but not negative 13. If I put negative signs in front of each of these terms, now again when I multiply them, I still get positive 30, and the hope is that somewhere in here I'm going to add them together and get negative 13. Negative 1 minus 30 is negative 31. Negative 2 minus 15, that's negative 17. Negative 3 minus 10, there we go. There is our winner. That gives us negative 13, but when multiplied together gives us 30. So 2 numbers that multiply to the last number that also add together to the second number. So when I do that, I'm saying negative 3 and negative 10. So x, let me redraw that. Negative 3 and negative 10. See, so x times x is x squared. I'm sorry. Some people can handle that, probably not all of you. So I will keep my letters the same. M minus 3, m minus 10. M times m, if I factor that or distribute this, m squared minus 10m minus 3m gets us that. And then negative 3 times negative 10 gets us positive 30. C, let's take a look at this again. We're going to look at writing out our factors so that they multiply to 81. So 1 and 81, 2 and 40 and a half, that's not very helpful. 3, whoop, what happened? There we go. 3 and 27, that works. 4, 5. Well, I'm going to stop right there because I know that 9 and 9 works, right? So, I'll skip to that. But I'm already looking at 81 and 1. When you add that, no matter what sign is what, that's not going to get 30. But 3 and 27, hey, look at that. All right, so again, I have a positive constant at the end. So the signs have to be the same. 27 and 3 have to stay the same sign, but they need to add together to be a negative number. So that means I have to be -3 and -27. So let's try that. So we've got y and -3, so y minus 3, y and -27. Okay, so if I check that out, I get my first two terms y squared, outside -27 minus 3, so minus 30y. -3 times -27 gives us 81. So we're cruising along. We got a couple of minutes left in the video, so let's push through D. D is a special case called the difference of squares, and what that means is I don't have that term in the middle. If you notice, I don't have just a plain x term like 4x squared minus 3x. There's just a constant and an x squared term. So I'm going to start this with the answer in mind. So 4 minus 2x. Actually, I'm going to go 4 plus 2x. 4 minus 2x. So a difference of squares, difference meaning that there's a subtraction or a difference between the signs. But if you were to check this, you would say 4 times 4, the outside terms, 4 times 4 is 16. That gets us what we need there. But take a look what happens. 4 times the outside term, 4 times -2 is -8x. Then your inside terms are 8x. So we have -8x on the outside, positive 8x on the inside, and those cancel out. So we had 16 minus 8x, and then we did the inside terms, we got plus 8x. So those together canceled out, and then the last term of each, 2x times -2x, is minus 4x squared. See, and that's how you end up getting 16 minus 4x squared. So how did I even know that? Well, you see enough of these. That's one way to, just through practicing that. But I want you to understand the deeper connection is that if I only have an x squared term and a constant, what happened was somewhere in the middle, the x term and the x term, the two middle terms, had to cancel each other out. And they do that by putting one sign as plus, one sign as minus. But if I keep the same values, then I have a positive of a number and a negative of a number. When I add that together, they cancel each other out. So we'll see that again in letter F here. But let's do E real quick. E is again back to more traditional. E we've got, let's go back to this color. So we need two numbers, so two numbers that multiply themselves to -32, and when they add, they get to -4. So 1, 32, 2, 16, 4, and 8. And yeah, we'll stop there. So I need to get this to be a -32. So one column is going to be negative. -1 and 32, that's never going to get me to -4. So I'm just going to, no, that's not working. 16 and 2. 16 minus 2 is 14. 2 minus 16 is -14. Doesn't work. Not going to happen. If I put -4 plus 8, that gives us +4. Okay, so we're close. We have a 4 in the end, but we're negative. So I need to get rid of the signages here, right? And I need to make 8 negative. 4 and -8 gets us -4. So t plus 4, t minus 8. If I redistribute all of that, you'll find that you get t squared, right? T squared minus 8t plus 4t, so -4t, and then 4 times -8 is -32. Yeah? All right. Moving on. That's all right. Oof, we're gonna be pushing the limit on this one, but let's keep going. Let's go back to black lettering. Kind of hard to see, so let me remove that. Okay. We have two terms. We have an x squared term. We have a constant. So I know that I'm going to have that situation where I have two parentheses. One's a plus in the middle, one's a minus in the middle. Now, when I do the first outside, inside, last, the FOIL, my first two terms multiplied together need to get me 36x squared. So how do I do that? What two numbers multiply to give me that? Well, 6 times x here and 6x here, when I multiply them together, I get 36x squared. Now, the other question I can ask is, how do I get myself 9/49ths? Well, there's a really fun trick to know. If I were to take two fractions, like 3/7 times 3/7, because that's really what we're going to end up doing. If I took a fraction times a fraction, you just multiply the top two numbers, and then you multiply the bottom two numbers, and you have a new fraction. So when I do that, 3/7 times 3/7, I get 9/49ths. And that is my answer. I'm looking for 9/49ths. So 6x plus 3/7, and then 6x minus 3/7. When I do that, if I FOIL this out, I get 6x times 6x, that's 36x squared. Now I'm going to take 6x times 3/7. Not sure what that is, but it doesn't matter, because 6x times negative 3/7 plus 6x times 3/7 in the positive, they cancel each other out. And then my last terms are 3/7 times 3/7, which gave us the plus 9/49. Oh, sorry, minus 9/49. Okay, so 6x plus 3/7 and 6x minus 3/7 is how you get that. All right, 12.5 minutes, that's plenty. I'll stop this and start another video and see how far we can get.